Yeah, have you drawn that?
Yes.
Okay, so now, for every circle, there is always a center, right?
Yes.
So the center here is the origin. Let me represent it with red. This is the center. You can see that.
Yes.
So the distance from this center, the distance from here, up to any length. Let's say you take a distance from the center of the circle up to anywhere you want, you can connect. This distance that you can see here is what we call R. Can you indicate that?
Okay.
And this distance you can see is equal. Like if you take another distance from this center to any part of the circle, we say that that distance is equal distance. They are equal, right?
Yes.
So connect this distance that you have here to x-axis. That is, you draw a line from here and then you connect it down this side. Can you do that?
Okay.
What have you seen? That distance is forming a right angle triangle. Can you see right angle triangle? The right angle triangle from here to here, that is a right angle triangle. So this is your x and this is your y. Can you indicate that? Have you done that? Have you done that? I can't hear you. Are we still together, Stephanie? You can hear me, right? This distance here from R and Y and X, can you show that?
Yes.
You have done it, eh?
Yes.
Okay, by Pythagoras theorem, we know that y squared, you see this y?
Yes.
So we can say that y squared, write y squared somewhere, plus x squared, this is plus, then you have x squared around here, x squared, this is equal to r squared, the one you have here. Can you indicate
Yes.
that? You have done that?
Yes.
Okay, so now, having done that, this equation here is what you will call the geometric equation or equation of geometry.
Yes.
So this equation of geometry, we want to rewrite it in standard form. So we make y the subject of the formula. You can see this side, right?
Yes.
Good. So if we make y the subject of the formula, what you will have is going to be y squared. This is y squared. So this is going to be equal to r squared, which is the hypotenuse, r squared, that is the hypotenuse, minus x squared. Can you see that?
Yes.
But we are looking for y. We are not looking for y squared. So to get our y is going to be r squared minus x squared. But now we take the square root of this side. Can you take that? Do that. Take the square root of this.
Yes.
You have done that, eh?
Yes.
So this equation here, this equation that you can see here, this one is what we call the equation of a circle in geometry. So we are going to integrate this function here in order for us to continue deriving this formula that we said that let me bring it down. You see this one here. You see this one here?
Yes.
Yeah, we have said that area is equals to pi r squared. So we want to show that indeed area is equals to pi r squared. So this is where we are. Stephanie, you have joined back.
Yes, above.
So write this. Have you written all this, eh? So now we want to integrate this. We want to integrate that. Let me raise this up a bit. So what we have now that we want to integrate is area is going to be equal to, you can see, eh?
Yes.
Area is going to be equal to the integral. The integration is written like this: from 0
Yes.
to r of this function that we have here, which is the square root of this is the square root of r squared minus x squared. In respect to x, write dx. But the whole of this, remember here we have how many quadrants? We have 1, 2, 3, 4, right? This is 4 sides. So multiply this 4 sides by this integral. So simply put 4 outside here.
Yes.
You have done that, eh?
Yes.
Now, this one that you are seeing here, this thing that you are seeing here is an acute angle. This acute angle can be seen as a cosine of theta. If this is an acute angle, which is a cosine of theta, we need to find what is cos theta. So take this up a bit and now write cos theta. Cos theta. Have you done that?
Yes.
Now, according to our sines and cosine rule, when we say that we are looking for cos theta, we know that cos theta is given as adjacent all over what? What is a cos theta? You remember Sokatoa? We have do you remember that?
Yes.
Do you remember this, eh?
Yes.
This one is a sine, and we say that sine is opposite of a hypotenuse, cosine is adjacent of a hypotenuse, and tangent is opposite over adjacent. So we are looking for cosine, which is adjacent all over hypotenuse. Is that okay?
Yes.
So now, what you will come here, since we are looking for sine that is adjacent of a hypotenuse, what it tells you is that this will be equals to r divided by, is going to be x divided by r. Have you understood that?
Yes.
Because here we have x. X here is our adjacent. R is our hypotenuse. And y is the opposite. You can see that.
Yes.
Stephanie, you can see that, eh? Okay, so now we are going to differentiate this. But before we do that, cross multiply. You know how we cross multiply, eh? Multiply r with this and this one with that, because we want to find what is x. So our x is going to be r cos theta. R cos theta. Have you done that?
Yes.
Yes.
But remember, we are still on this Cartesian plane. So it means that we are not interested in all r, because we know that for the equation of a circle it is r squared. So you are going to take the square of that. So square this side everywhere. When you square, this will be x. It will be x squared is equals to r squared cos squared theta. Can you do that? You have done that, eh?
Yes.
Yes.
So now that you have done that, we are going to differentiate these two things. We are going to differentiate. Differentiation. Differentiation. This is what we are going to do now. Yeah, we do that. Let me take this up. You can see that, eh? So if we differentiate this value here, x, what do we get? We will get dx. We will get dx. When you differentiate x, you will get dx. Dx. You can see dx. Write dx, eh? And this is equals to negative r sine d theta. Because when you differentiate a cosine, this cosine here, you will get negative sign. Simply bring the negative sign upward in front and write this. So this is what we have now. Now take the whole of this and rewrite our equation that area is going to be given by, bring this negative that we have here outside, is negative 4. Remember that we have this here before. You can see what we have here, eh? Can you see? So this is what we want to rewrite here. So this is going to be the integral. We know that we are going to look for what can be represented in terms of our boundaries. What we write here and here is the boundary, but look, leave it that way now. This will be the square root of r squared. It is r squared minus x squared. But now we are representing this in terms of r, so everything is going to be r. So r squared minus r squared cosine of theta, extend this square root up to here. Now multiply the whole of this by what we get here, which is r sine, that is r sine theta, but now is going to be d theta. The negative sign is now here.